So in our last video, we looked at creating this differential equation to determine the velocity of the skier as a function of time. And in this part 2 of this video, we're going to learn how to solve this differential equation. So we'll start out with the differential equation that we had. And our very first step is something called separation of variables. Our first step in separation of variables is multiplying both sides of our equation by dt. So we're really multiplying this whole expression by dt. On the right-hand side, that dt cancels out with the dt in the denominator of our derivative. And on the left-hand side, I could distribute dt to both terms, but I'm not going to. The other thing that we want to do is get anything that has a v on the other side of the equal sign, so it's on the same side as the dv. So in order to do so, we're going to divide both sides of our equation by that expression that's in parentheses. So in the end, we end up with just dt on the left-hand side. And on the right-hand side, we have m divided by mg sine theta minus bv. And then all of that is times dv. Once you have the variable v and the dv on the same side of the equation, and you have the dt on the other side of the equation, you're done with that separation of variables step. This usually is enough to get you 1 point on the free response section of the AP test. Our next step then is to integrate both sides. We're going to do something a little different here than what we've done with integrals, and that's something called a definite integral. In physics, we often do a final minus an initial quantity, and that can be done with a derivative here by putting your initial on the bottom here and your final on the top. So at time equals 0, we know that the velocity is 0. And at time equals t, we're going to come up with an expression for the velocity v. So those are going to be my limits on the integral. We'll talk about what that means when it comes to taking the integral later on in the video. The left-hand side of my integral is a relatively easy integral because when we do the integral of dt, the answer is just t. And we're going to evaluate that t between 0 and t. The right-hand side is a bit more complicated. We have to use a skill that's used in calculus called U substitution. In U substitution, we're going to set a quantity equal to U. Specifically in this case, we're going to say mg sine theta minus bv. We have to do this in this case because this is not a simple polynomial expression, and at least as of right now, those are the only expressions we know how to take the integral of. When we do u substitution, we say the variable u is equal to a portion of our expression, and then we're going to take the derivative of u with respect to v. So v here is my only variable. M, g, and theta are all constants, and we know the derivative of a constant is just 0 minus the derivative of b times v, and that derivative is just b as in boy. So 0 minus b is just negative b. If I do a little bit of algebra, I can find that the quantity dv is equal to du divided by negative b. Or another way of writing that is negative 1 over b times du. I'm going to plug that into my expression over here. So I'll have the integral of m times negative 1 over b du. Oh, I forgot the u down here. That u is what took the place of the mg sine theta minus bv. And that negative 1 over b times du is what took the place of the dv. I am leaving these limits off. You know how I had 0 to v initially? I'm leaving those off for now because now I've changed the variable from being the variable v to being the variable u. When I evaluate these limits, basically we'll wait on evaluating those limits. Let's leave this left-hand side of the equation as it is here. On the right-hand side, I can pull out my constants. M and b are constants. So I have the integral of 1 over u du. You'll learn in calculus class, as well as can be found on the equation sheet, that the integral of 1 over u du is simply the natural log of u. Again, that's something else to memorize for calculus, but you can find it on your equation sheet in AP Physics. So our next step is to plug in our expression for u. And I'm going to start working up over here. So I have t between 0 and t is equal to negative m over b times the natural log of the expression mg sine theta minus bv. Now, to make my life a little bit simpler, before I plug in those limits from 0 to v, I am going to go ahead and multiply both sides of my equation by the reciprocal of this. So my left-hand side will become negative b times t over m, evaluated between 0 and t. And my right-hand side becomes the natural log of mg sine theta minus bv, evaluated between 0 and v. When we have limits on our integrals, the way that we handle those is we plug in the upper limit, or the final, minus what we get when we plug in the lower limit. So my left-hand side of my equation would have minus bt over m minus b times 0, that's my lower limit, over m, so that's just 0. On the right-hand side, I have the natural log of mg sine theta minus bv minus the natural log of mg sine theta minus 0. Now, I need to simplify this because my end goal is to solve for, to make an expression for v, the velocity as a function of time t. So the rest really is just algebra, though it will take us a little bit of time to actually get through that algebra. So again, I'm going to come up over here. Starting out, my left-hand side of my equation is negative bt over m. On my right-hand side of my equation, I have the natural log of one expression minus the natural log of another expression. There's a rule with natural logs that says if you're subtracting two of them, you can actually divide what's in parentheses after the natural log. So really, this can be expressed as mg sine theta minus bv divided by mg sine theta. Now, I eventually want to solve for that v again, just keeping in mind what we're trying to do. And because that v is in a natural log expression, the way to undo that is to do that exponential raised to that power. So my left-hand side becomes e to the negative bt over m. My right-hand side, the e and the ln cancel each other out. So I have mg sine theta minus bv divided by mg sine theta. I can rewrite the right-hand side of this expression as 1 minus bv over mg sine theta. And then I can do a little bit of algebra to get bv over mg sine theta equals 1 minus e to the negative bt over m. And then lastly, I am going to multiply each side by the reciprocal of that constant to get v by itself. And you'll see that my final expression uses only the variables that I was told I was allowed to use in the problem. Now that was a ton of work to be able to solve this differential equation. Guess what? On this particular free response problem, this whole part was only worth 3 of the 15 points. One of those 3 points is just that separation of variables. The other 2 points are for all of this calculus and algebra. So grand scheme, it takes a lot of time. So if you are pressed for time, this is probably a good part to skip, but it will be really useful that we understand how to solve differential equations, especially when we get to our electricity and magnetism. The last part of this free response question deals with graphing the acceleration. And we know that acceleration is the derivative of velocity. So one of the things that you will learn in calculus is that the derivative of an exponential function is also an exponential function. So just knowing that means that we know that this is going to take an exponential curve shape. It eventually goes to 0 because at terminal velocity, the acceleration is 0. And the last important thing we can do is come up with an expression for that initial acceleration. That initial acceleration occurs when velocity is 0, which means your resistive force is equal to 0. Therefore, the net force in this case, parallel to the incline, is just that component of gravity that is parallel to the incline. And that equals the mass times the acceleration. So we know we can express that as mg sine theta. That's equal to mass times acceleration, and the masses cancel out. So this initial acceleration is g sine theta. Again, this was a lot of new concepts for those who haven't already completed a calculus class, and so I don't expect you to be experts at solving differential equations yet. Getting to that point where you at least somewhat understand what we just did in this video would be a good first step in understanding how to solve these differential equations.